Of course, it's very useful to calculate summary statistics for each column of the data frame. However, sometimes we may want to do things at a more granular level. And to do that, let's take a look at this example data set. This is a data set about several products a company carries in stock. As we can see, we have several mugs of different colors, a product that is a glass, and several plates, again in different colors. We also have the information of the selling price and the quantity in stock for all those different products. Let's go to Jupyter Notebook and try to load this data set. Actually, let's first go to Avenue to Learn. Under the dataset for in-class example section, we can find this dataset, product.csv. And this time, let's copy the GitHub link. So in order to load this dataset, we first need to import pandas as PD. And then we will do products. That will be the name of the data frame. So pd.read_csv, and we need to supply the file path and file name as the input argument for this function to read the dataset. And here we're providing simply the remote URL to read the dataset. After reading the dataset, let's try to have a quick peek into the dataset using the head function. Let's do first 10 rows. And turns out there are only 7 rows. So we are seeing all the rows by using the head function in this example. Of course, we can do the same thing as what we have performed, like calculate the average price for all the records, calculate the average quantity for all the rows. But this time we want to define groups. How do we define groups? Looking at this data frame, it's actually easy to see that we have different types of objects and we have different colors for each object. So a quick way to define groups will be to look at a categorical column, let's say the object column. And then before defining groups, let's take a look at the unique values in the object column. So let's do the data frame products. We're going to take the object column, and then we're going to call this function unique. We will get the unique values in the object column, right? As we can see previously from the data frame, we have mug, we have glass, we have plate, right? We have 3 unique values. In total, there are 7 values, but then there are only 3 unique values. We can also get a bit more information than just the unique values. So let's take the object column again. This time let's do value counts. And this value counts function not only gives us the 3 unique values, mug, plate, and glass, but also tells us how many rows has the object equal to mug, right? And also how many rows will have the object plate, and how many rows will have the object glass, right? 3, 3, and 3, which is indeed the case in the data frame if you do a quick exam. Now, we have 3 unique values in the object column. It means that we can define 3 unique groups, right? Basically, we can have all the mugs being one group, all the plates being one group, and the glass being one group by itself, right? So we can define three groups based on the type of the object in the object column. So let's get started with performing the grouping operations. We start by grouping the whole data frame based on a single categorical variable. So we're gonna do products, the name of data frame, and then use the method, group by method, that is attached to any data frame instance. We need to group based on a certain categorical variable. Here it's going to be object as an example, right? So we're gonna take the products object column and then perform group by based on this column. And the result will be stored in a Python variable we call grouped. And then what we can do is to quickly look at this grouped variable that contains our result. The grouping operation is successfully done. However, the result variable grouped is not very intuitive to understand. So if we look at the type of this variable grouped, it tells you is some kind of data type called data frame group by, right? Sometimes we say it's a group by object. It doesn't tell you much, and we can understand the grouped variable as an outcome of the group by operations to be some backend operations that divide the whole data frame into groups based on the unique values of the object column. Right? It doesn't show you much information, but things will become more intuitive once we start some follow-up operations for this group by object that contains the results of the grouping operations. All right, so this time let's do this. So we're going to look at the grouped variable, which is the result of the grouping operations. And then we're gonna calculate the mean values for the different groups after performing the grouping operations. Right? Here I'm gonna again invoke the numeric only equal to true argument. And that's because in the data frame, we not only have numerical columns, we also have categorical columns like color. We cannot really do mean values for any non-numerical column. So after grouping, I calculate the mean. Let's assign the result to a variable called mean group. Right? So then we can display what's inside this mean group result. So this time things become more intuitive. We have three individual groups based on the object column, glass, mug, and plate. And then we have two numerical columns, price and quantity, in the original data set. So what this operation of calculating mean for a group by object give us is that for every group, I'm going to calculate the mean price and also the mean quantity. So let's go back to the original data set. We can see that there are three mugs, row 0 and row 1 and row 4. And corresponding to those three mugs, we'll have three price values, 5.67, 4.28, and 5.12. If you average over those three price values, you will get this value here, 5.02. Same thing for the glass group and the plate group. Also the same thing for quantity. Right? So the idea is that I define groups based on the unique values of a certain column. Here we have three groups based on object. Then within every group, we can calculate the average value for each numerical column. The type of this group.mean operations or function is going to be a data frame, right? Because data frames are essentially tables. When you see a table being displayed by Jupyter Notebook, you know the outcome is a data frame. So we just grouped the entire data frame based on the categorical column object. Sometimes we may be interested in only calculating some statistics by group for a certain particular numerical attribute. Let's say we're going to calculate the mean prices for the different groups based on object. So this time we're only interested in the price column. Right? So we take the price column and perform a group by. And then to do the group by, we need to tell the function based on which categorical variable we want to perform the grouping operations. At this time, the same as before, let's do products object. Now we're taking the object column and perform grouping based on the unique values of the object column. Again, let's return the result to a Python variable called grouped. Okay, the grouping is done. Again, it's not going to be very intuitive. However, we can make it intuitive by further calculating some summary statistics for the individual groups. By this time, let's do grouped. That's the group by object returned by the grouping operations. Group.std will be the standard deviation. And we don't have to specify numerical true because currently we're only focused on the price column, and we know that the price column is for sure numeric after examining the original data frame. So I'm going to just call the result std grouped. And then let's display the result. Again, because we grouped based on the object, we have three unique values: glass and mug and plate. That's three different groups. For each individual group, we calculate the standard deviation. Right? We have three rows that has the object mug, so correspondingly we will have three prices for the mug group. And then we can calculate a standard deviation based on those three prices. That's the standard deviation of prices across different rows in the mug group. Same thing for plate. But one thing interesting to notice is that the standard deviation of the glass group is actually not a number. Why exactly is that? Well, if we look at the original data set, we'll find that there's only one row that has the object glass. And correspondingly, there's only one price. And we cannot really calculate standard deviation based on one value. Right? That's why for the glass group, there's only one member in the group. Then we cannot really calculate standard deviation for that group. So the result is not a number. We can also quickly check the type of the std grouped, which is the standard deviation by group result, right? So this time it's actually a series. That's because we started by taking the price column, and then we grouped based on the object, so we'll have three groups of prices. For each group, we calculated the standard deviation. That means we'll have three different standard deviation values, forming a column of data, which is a series, instead of a frame, which has a tabular structure. We just grouped based on the object column. but turns out we can also group based on several categorical variables. To do that, we need to provide the list of categorical variables you want to use to define groups. For example, let's say, again, we're going to group products price column, and we're going to do group by, but this time we're going to group based on two columns, object and color. So we need to provide a list inside a pair of square brackets. In that list, we need to provide two categorical columns. The first column is the products object column, and the second one is products color column. And we can put the results of the grouping operations into a Python variable called grouped, and then we can use grouped dot mean to show the prices, the average prices by group. So this time we actually have 5 groups based on both the object and the color. For each group, I calculate the mean price. Let's take a quick look at the original data frame. Well, this time I'm considering both the object column and the color column. It means that, for example, for mugs, the 2 red mugs will be a group. That's group number 1, let's say, right? And for the blue mug, that's a different group, right? This time we are considering both object and color. If one factor is different, we have a different group. Right? So that's the second group. And we also have white glasses. That's the third group. Now we are left with the plates. We actually have green plate, 2 rows, both being green plate, so that's the third group, right? Well, actually, the last row should be the second row that has green plate. So those 2 will be a group. Finally, the last group is going to be the blue plate, right? So that's how we define groups for more than one categorical variables. Right? Turns out we have a total of 5 groups. And that's 5 unique pairs of object and color values. Finally, we can also group several numerical variables at the same time based on several categorical variables. So this time, let's first look at the data frame, and then for this data frame, let's look at a list of 2 columns. Right? Let's say I'm not only gonna divide prices into groups. In the meantime, I also want to look at the quantities by groups. Right? I'm gonna take 2 columns from the data frame and then perform a group by operations. When I'm doing group by, if I'm considering more than one factors based on which I will do the grouping, then again square brackets to include a list of columns. Right? So the first categorical column is products object. The second will be products color. And that's again 2 factors. based on which we're going to define groups. And then the results will be called grouped, and something not very intuitive, but the grouping operation is done here already, right? And we can do grouped dot mean. Again, I don't need to use numeric only because in the very beginning I have selected price and quantity, both are numerical columns, right? And let's look at the mean result. And this time it's a data frame. It has a tabular structure, right? Because we are grouping more than one numerical column, right? So we can see that we have a total of 5 groups, just the same thing as on the previous screen. But this time we're calculating not only the average price for each group, but also the average quantity for each group. Okay, so like for mug, we have blue and red. So blue mug and red mug will be 2 different groups. And inside the group blue mug, we'll have 2 values, right, 2 rows for blue mugs. And each row will have a price and a quantity. So what is shown here is for blue mugs with 2 rows, I'm giving you the average value of those 2 rows and the average value of quantity of those 2 rows. Okay, so that's basically what's going on with the group by operations.